on this computer. There we go. So as we said, we're trying to decide how do we validate a claim. And so what makes a claim valid? What are the deciding factors of a valid claim? Do the actual dice matter?
What do you mean by actual?
Like, can I only claim what I have? Like, do the dice I have dictate what I can claim in the rules? What is that? No, right? I could say whatever I want, right? Based on my dice, but the restrictions we know are these rules right here. The rules must increment either the value or the count of the previous claim. So the only thing that our new claim has to be related to is the previous claim. We don't actually need to take any of the dice on the game field. I don't need my dice. I don't need the other player's dice. My claim just has to increment one of the numbers, or at least at minimum increment the previous claim's value, minimum. So I can increase one or both. As long as if I increase the value, if I increase the value, I can reset the count. So those are kind of our requirements there. So there's a couple ways we can look into, well, what's our order here? How do we want to justify this? And really what you want to do is try to get an answer that the item wants as quickly as possible. So if someone gives you a claim, you want to be like, well, how quickly can I say no to this claim? Again, we know that there's 3 types of claims we can make. Just to make it a little easier to follow. There's 3 types of claim. Increment both. Increment just value. Increment just the count. But we cannot, there's also the 4th one. What's the 4th type of thing our player is allowed to do? Tricky one, yeah. One of the things we got to think about all the scenarios. So I can know
increment the value, but decrease the count.
Yep, exactly. I can increment value, change count is all I'm going to say. Because I could technically increment the count too, but this is trying to count the other concept where instead of incrementing both, yeah, we technically increment value and reset count, because you can set reset or decrease count. And so there's 2 ways we could approach a challenge like this when there's a yes/no question. Does anyone know how you can approach a yes/no question? Any ideas?
True, false.
Yeah, the first way is to say, well, let me just do everything I can to prove false. And if I cannot prove it's false, well, then I know it's true. And I can just return true. And so the default behavior is return true. And what my goal is to prove that the claim that they made is not valid, that they can't make this claim, because maybe that's easier. The other variation is, yeah, I can try to confirm that they did one of these 4. And if they didn't do one of these 4, then I can return false. So if one of these 4 is true, then I can return true, otherwise return false. So there's 2 ways to approach this. Either the default behavior is return false, the default behavior is return true, and I'm trying to find the opposite. So let's do a quick little sample item. If I have a claim of 3 3s, so 3 3, and I have a claim of X, Y, any ideas how I could compare these 2 and quickly say that this one is not valid? Let's start with that round first. How could I prove that this claim, whatever it is, regardless of what I know it is not valid?
If it's the exact same thing as 56.
Well, that's one option, right? We can see first to see if this is both X and Y are equal to the X and Y here, to these 2. So for our new items, so let's try that. So if new claim 0 is equal to claim 0, and new claim 1 is equal to claim 1, We can S out. Error. Oop. Not that. That. Error. Must be a new claim. That way the player knows why we're kicking back their claim. Return false. There's one week we can confirm that this is not valid. They made the exact same claim. We've already said, nope, I don't want to check anything else. I don't need to know anything else. They sent me what I already had. Have it back. I don't want it. What else can we do? What else can we check for? Go ahead.
Check if the value is the same. So if it's still guessing a certain amount of threes, but the count of threes is less than what was previous. So like if they did 2 threes instead of
so check to see if the claim went lower.
Yeah.
So if the new claim's value went lower. And so again, this is where we have the slight issue with, again, remembering using 1 and 0, which one's claim, which one's value. So we know that if you see here, this is count, this is value. So 0 would be the value. So new claim 0 is less than claim 0. It might be easier to do this for us. So what I really want to show is one way you can fix this problem with the array problem, with the array indexing. I'm going to do this just so you see it. Private int. Now I'm actually going to call it final, actually. Int claim value equals, we know that's 0. Claim count is equal to 1. This way, our items are going to be a little easier to type. So instead of seeing 1 and 0 all over the place and not knowing what it is, now we can do claim, give me that. Claim value, nope, that's the claim count. This one is now going to be claim value. That way it's a little easier to know what's what. Now I don't have to keep trying to remember which one's the value, which one's the count. And this one doesn't really matter whether or not I get it right. As long as the two are the same, we're happy. Claim value. Now claim value. If the new claim's claim value is less than the old claim's claim value, we know that's wrong. They can't, in no situation are they allowed to decrease the value, right? The value of the die must either be the same or increase, one or the other. So that's the case. We can again S out, tell them what's wrong. Die value must be same or increased. Or you can change, again, the error message, you can say whatever you think is going to make more sense to the player. If you want to say that die value cannot be decreased, if you think that's an easier error message, that's fine too. So however you want to word this doesn't really, the wording doesn't actually matter. So just try to find the wording that makes most sense to you. False. So now here's a logic question. And this is where being able to make deductions based on what you've already said. So if this is true, sorry, if this is false, meaning we didn't trigger this, and if this is false, what do we know now about the value or the count? We should be able to deduce something about these values. So if we hit line 67 now, meaning that this came back false, this came back false, so these both figured false, is there anything we know for sure about either the value or the count? Well, new value. A type of logic. So what we tested is we tested that the new claim count is, if both the claim count and the claim value are equal to each other, that's the problem. So we already know as of line 63 that the count and the value are not the same as the original. As of line 63, we test to see if the new claim value is less than the current claim value. So we hit this line, what is the one thing we know for sure?
It's a valid claim.
I don't know if it's valid yet. So the deduction we can make from here is that we know for a fact that new value is at least greater than or equal to old value. We know that beyond a shadow of a doubt now. As soon as we hit this line, we know this 100%. There's no chance this is false. Admit. We can add this equal sign here because we only tested if both items are equal. If this was true, but this was false, this would still trigger false, so it wouldn't trigger out. That's why we can keep the equal sign here. But we don't know anything technically about the new count yet. We don't actually know anything about the new count. All that we know is that the new count and the new value do not match the old value and the old count. But the one thing we definitely know for sure as of this line is that the new value is guaranteed to be either equal or greater than the old value. So at least the value side, we can be confident that is good to go, right? So what I wanted to clarify is, Colin, you're close. We only know that the claim is half confirmed, right? We know that the value is valid. Value is valid now because the value can either be the same or incremented. We know that the value has been either left the same or it's incremented. So we know the value is valid. That number is allowed. We now need to figure out if our new count is a valid number, and that's based on new value, right? What are the rules again? So let's do this two scenarios. So there's two scenarios for the new value. The new value is either equal to old value, or new value is greater than old value. In the two situations, what is the rule for a count, for new count? So if old value and new value are equal, what has to be true about new count? What has to happen?
Has to be greater.
Correct. Good. New count must be greater than old count. It has to be. And then the other item, so if new value is greater than old value, what can be true about new count?
It can stay the same,
It can stay
or
the same.
I guess it has to be at least 2, correct? Or
Not
does it,
two.
I'm trying to remember the rules of this. Does it have to be the same count as the previous claim, or can it decrease?
So that's where this is where the little trickiness comes into play. So yeah, as soon as you increase the value, your count can now be reset back to 1. So in this case, you have to increment the count. If the new value is the same as the old value, you have to increment the count. Otherwise, this would have triggered true. In the sense where the new value has been incremented, well, now your count can be anything as long as it's above 0. It has to be greater than 0. Do we know that it's above 0? Is there any way to know for sure that our claim count is above 0? You wouldn't know this, Colin, because you weren't here last week, so you missed this part of the code. When we get our claim, do we set that limiter where they have to give us a number above 0? Anyone remember? Look, see if you remember now. I don't know why that happened. We get claim. Remember this? How many are die count? We did set a min max of 1 to 14. So back to our LiarsDice. If our new value is being incremented, our count can be whatever was given, right? Our count is all set. Count is good. We don't care what count is. Count can be the same. Count can be back to less. It can be any number that they're allowed to pick, which is 1 to 14. As soon as they increment the value, their count can be any number between 1 and 14. Doesn't matter. Now we're good. So how many conditions do we need now? How many conditionals do we need? We know this returns true. If the new value is greater than the old value, the count is good. We need to ensure that if the value is the same, that our count went up. Because what could it be? Remember, we don't know anything about count. We don't know what they did with the count yet. We know for a fact that, like we said before, we know for a fact that our old value is greater than or equal to, our new count value is greater than or equal to our old value, but we don't know if old count is actually greater than new count, right? Sorry, new count is greater than or less than, or we don't know what it is compared to old count. This didn't test anything, did it? Nothing here really compared new count to old count, to the original claim. Did it? So we do need to test that. So if our new value, which is going to be, new value, new claim, claim value is equal to claim. Yeah, what happened there? Cursor moved. Claim value. We need to make sure that our new count is greater than the old count. So we can do and now we're looking for the negative. So we don't want to test this. This is not what we want to type in because this is what we want, right? We want our new count to be bigger than our old count. So what should we check? For the negative, to check for falsity. So our new claim is equal to our current value and our new value and old value are the same. How can we make sure we're looking to make sure that this is not the case? We want this, but we're looking for the negative. Remember that. So what can I type here? Anyone know?
If new, no,
you go
go
ahead.
Nah, you got it.
I was gonna say if claim count is greater than new claim count.
It'll work. Yeah. If our new claim is less than, or if the original claim is greater than the new claim, well, they tried to keep the value the same but decrease the count, and they're not allowed to do that. This one, error. Increment at least one value, one item. Must increment at least one item. Again, if you guys can come up with better error messages, that's great. That's fine. So now, if we hit this point, if we get past this point, we know that our new value is greater than old value. Let me go ahead and clear all this stuff out now. So let's see. We're pretty confident now, based on our logic that we came up with, that the items are not the same. So the two numbers cannot be the same. This would trigger it back. If our value is less than new value, if our new value is less than our old value, we already killed it. So our value must be equal to or greater than. If our value is the same as the original value, then we check to see if our claim count is less than. And if it is, we kill it out. So it means here, if our new claim is the same as our old claim, we know for a fact that our claim count is greater. It has to be greater than the original one. Also, I guess we don't need that because this would have checked that. So we know that if our values are the same, our count is definitely greater than, because that's this. We also now know that if our claim is not the same, it has to be greater than our new value, and that means our count can be whatever it wants. And so that means if we hit this line, our claim is true. Now, how can we confirm that? A lot of you probably are just taking my word for, like, if Cliff says so, then fine. So instead of taking my word for it, let's say you were doing this on your own and you're like, I think I got it. This seems right. It logically makes sense. How can I check this? Any ideas? How would you confirm it? Nothing fancy. All you do is you actually would run through a couple of your own scenarios and just test it yourself. And so if I say again, value and count as 3, 3, well, now I can say, you know what, let me test. Well, if I send in new value of 3, 3, well, this would trigger true, and this would trigger true, so I'd kick it back. I already know that's false, so that's what I want. Let me try another one that I know is purposely wrong, 2, 3. I know that's wrong. I know this one's going to catch it. Oop. This one's not going to catch it now because this is no longer true. This is going to come back false, so this if statement's not going to kick it back. Is this if statement going to kick it back? New claim is less than the current than the original claim. Is that true?
Yeah.
Right. This is the, oh, I probably should clarify that. Old. Or this is claim. 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 Value. Count. Is that clear to see? So this is now going to be true, right? So we're going to return false. So yeah, this is a bad claim, and our second if statement is going to catch that. Well, I know that. Let me just check another really bad claim. Let me do 2, 2. Both have been decremented. Both decreased. We don't check for anything that specific. So now we want to know, is this going to still kick back? This should kick back, or do we not check everything? Well, let's see. Our new claim is equal to our old and to our new. Well, that's not going to happen because these are both different, right? So both false and false. So this if statement is not going to catch it. Is this if statement going to catch it?
Yeah.
All right. Again, we don't care about the count. We already said as long as the value is negative, we don't care what the count is. That's already negative. That's already a bad thing. We don't care anymore. So that's going to catch it. So this is still good. Let's test another bad one. We know that if we decrease the count but keep the value the same, we want to check and see if this catches this one next. So let's see. Does our first if statement catch it?
No.
No, because our counts are not the same. So that's going to be a false and has to have both true. Is our second if statement going to catch it?
Nope.
Nope, because our values is not less than. Does our third catch it? Well, we know that the values are the same, so we know this trigger's true. Is that true?
No.
Are you sure? Our claim count greater than our new claim?
I'm sorry. Yes.
Yeah, that's true too. So both of these are going to trigger true, which means we're going to, didn't notice that. We're going to also kick out. So this one will catch this situation. That's good. And so what's really nice about doing this little situation here is if you didn't think about this scenario, and let's say you didn't have this code here, by testing it out, you would realize, oh, I have another scenario that I didn't catch. So that's why doing this a little bit of kind of running through your own code line by line, following the flow, can really help you to realize, oh, I'm missing something. It can help you catch mistakes before you go forward. So walk through your code. Don't be afraid to be like, all right, well, I know all the bad things I could do, all the ways I can put in code that will be bad and not a valid claim. So let me try those and make sure my code's going to catch it. Make sure it won't falsely validate something. Is it possible you might not think of one? Yeah. But just by doing this simple little quick check, you can rule out a bunch of mistakes and realize, oh, I need another if statement. So this catches that. Well, let's test out 2 good claims now. So we'll do value 3, count 5. This should hit the true line. Is that going to trigger?
Nope.
Nope.
No.
No, this is going to hit false, right? We're good there. Will that trigger true?
No.
All right,
Nope.
the values are the same, so this is going to come out false. Is this going to trigger true? We know the values are the same, so this is true, but is this going to be true?
Nope.
Nope. So we'll hit return true. So yeah, valid claim is allowed. Let's test another one. We're going to say the values increased. Let's keep the count the same for the moment. So we did the increment 1, the increment value only. Is that going to catch it and say kickback, or is that good? That might be true, but this one's going to be false, right? So we skip that. True or false?
False.
All right. So we're going to skip that as statement. True or false?
That is false.
False. And one good thing of this is as soon as this triggers false, it won't even check this. So don't even worry about checking it. As soon as the first line of your statement considers false, it just moves forward. Return true, we're good there. And in the last scenario, we increment the value but decrease the count. Let's see if our system allows it. True or false?
False.
False.
Good. True or false?
False.
Good. True or false?
False.
And we go straight to the true. Looks good, right? There we go. So we know that this claim is allowed, so we can now return true. Okay, so now we know that we can get a claim, we can confirm it, but now we need to know if they didn't claim it correctly. So now we know our is claim will actually say yes or no, which means we can now keep asking the user until they give us a valid one. Well, if we want to keep asking our user until they give us a good one, what sort of loop should we use on that one?
Well, true.
Do the while true. What was the other one we came up with too? Came up with another one.
Do while.
The do while, right? Where we guarantee a one run and we don't have to use the brakes. Now that's something you could do. You could do, I will show the other variation because we do have a do while already. But to see what the while true looks like on this case. Move those up. It. There we go. And what would happen is we would just do a simple if is valid new claim is true. If it's a valid claim, or sorry, in this case, we'll do the negative. If not is valid claim, we will, oh no, oh, sorry. If is valid claim, we are going to break out of the loop. So if the claim is valid, we will go ahead and break out of the loop. So that would be the while true. The other variation, of course, would be the do while, and how that one would look like is the do copy this stuff, set there, but we're actually going to take this guy and do something a little different with it. We're just going to take this piece here, cut while it is not a valid claim. And so what happens here is that we're going to keep looping until they give us a valid claim. And so that's the do while variation. So while true, do while. See how the change works? All right, good. Now the main thing I want to clarify, I do want to catch one quick thing, because either no matter what, after we know that the claim is valid, we're going to overwrite the original claim. So claim equals new claim.
Wait, should we be getting the claim from players or player?
Player, because we pulled player out from players. So we did the while true run term players.get active player. So we'll be pulling the player from the players array.
Okay, no, because I think further down, yeah, on line 53 was confusing me.
Gotcha. Yep. Oh, I did that. Oh, thank you. Good catch. I don't know why I did that. Player.get claim. Good catch. I totally missed that. Good there. So we're gonna do the same thing here. Good catch. So
Cliff,
yes.
only because I didn't do a do while loop, but I did, instead of doing the putting do, I put the while conditional where the do is, and then inside I just reassigned the new claim to player.get claim. Is that the same thing?
Close, because what I was about to showcase is that this guy here, because we want to do the claim after we know that they've given us a good one, if we didn't have that line there and we did like this, we're going to have an issue because new claim is currently still scoped within the while loop. So you notice here how if you do the while true, I still need to do what I did for the do while, which is initialize new claim outside so that the claim can then be used once we pass the loop. This is one of those new things you have to deal with that JavaScript didn't have to worry about. Scoping was not such a big issue with JavaScript as much. It's definitely a lot more of a concern inside of Java. So with dealing with loops, a lot of times, just kind of keep in mind that if you're probably not, you might end up needing to create the variable right before you do the loop. Now, I do this like this because I don't want to create this if I don't need it. So if the player decides that they're just going to call the lie, why even create the claim array and take up memory? So that's why I do it like this.
So that'll get created even if that return is called?
No, this one will not get
45?
created if we hit this line.
Yeah.
Yeah.
So,
Now, if I
but
moved it up
if-
here, it would. Now, if I was
Yeah.
up here, it would get created no matter what.
What's the, sorry to ask, what's the short key to move lines of code up and down?
I just found that out last week myself. Alt-Shift.
Alt Shift, okay, thank
Hold
you.
down those two. Yeah, it was the Alt key with Visual Studio Code. I found out it's Alt and Shift held together allows you to move a line up and down. So I was
Okay,
so excited
thank you.
when one of the cohort 8 students told me how to do it. I was like, yes. I missed having that ability to do it. That was a nice feature that Visual Studio Code had. So yeah, I found that out last week. It's been my favorite thing to have back. So I'm going to actually keep this code here as commented out so you can see what the difference is between the while true and the do while, see how it works. The while true can allow you to do the true statement while the do while looks for negativity. So again, it's just keeping that mindset of do this until I get what I want. And this says, well, do it until, again, I get what I want. And this just says, the way it's checking to see if we got it is say, once I have what I want, I'm going to stop looping. This one is just the literal do while I get until do while I'm not getting what I want. So it says do while, and once I have what I want, while true. So keep doing this. Once I have what I want, exit the game or exit the loop. I'm happy. I'm going to break out of, I'm going to stop asking you the same question over and over and over again. All right, so we got that. Claim new claim, then we can return. And what this case is, we want to do this. So we ran the turn. We currently aren't returning anything. If we look back here, we have again a run true. I want to uncomment that for a second. I don't know why I commented that out. So while true, we want to run the turn and get the player's decision, get the player to run their turn. Well, there's one problem here, right? What's the problem with this line, with this bit of code right here?
That is going to run forever.
Yeah, we aren't really ending the turns. So there, we did mention this last week. There's at least one behavior we know that's going to end the back and forth between the turns. So as the game goes through, you're going to keep going back and forth between the two players or between the players. You're going to keep going from player to player to player until a certain action occurs that ends the quote round, that starts the end of the round. What was that action again?
Calling a lie.
Yeah, calling a lie. And so what we really want to do is just say, what we can really do here is actually say, you know what? I'm going to run the turn, and then we'll have a, if run turn returns false or returns, let's say true, we'll keep playing. If it returns false, then we know that the turn's going to end, right? We can even do the other way around, however you want to end it, however you want to run it. You can even say, you know what? If it returns false, that means we're going to keep the turn isn't over. If it returns true, that means the turn is over. The turns are over when it move on. So we can decide. It doesn't really matter which one you use. So run turn, and we know that the return is going to return. That the run turn is going to return. Continue game. Do that. Boolean. And continue game equals that, and that means we needed to return Boolean. And so in this one, we're going to say return lie, so we're going to return false. We're not going to continue the turn. And I goofed that up. I'll undo that. I added a 0 there for some reason. There we go. And turn. So if the item if we turn false, we don't continue round. Sorry, continue round. And if they make a new claim, we want to return true, continue playing the game. So once we get a new claim, we're going to keep playing the round. The round continues. If they call a lie, we're not going to continue the round anymore. So false, continue round, false. And that is, we can do if not continue round, break. So if we're not going to continue the round, we're going to end out of this while loop, while true. So far, so good. This is going to allow us to end the back and forth of going from player to player to player. And if we, now the next question, of course, if we don't end the turn, what do we want to do? We want to make sure the next player plays, right? How is it making sure that, how are we playing each player? How do we get the player?
By indexing.
Yeah, we use the active player variable, which is keeping the index. We move from player 0 to player 1. We then want to go to the next player. Now, I do want to say, again, this is where I may have gone a little bit too evil by having you guys start with just an array of players instead of just 2 players right from the get-go. You could have started with the code with 2 players and then added in the item later on. But I am going to introduce you to this concept of looping through numbers. And what we'll probably end up doing is having a small little algorithm challenge tomorrow before class starts to learn a little more about how modulo works. So modulo is our key item here. Who knows what modulo does?
Checks if there's a remainder when it's
So
with division.
Yep, this is the symbol, the modulus symbol. And so if we do, just for the fun of it, let's go back to my main class for a second. Anyone know what the result of that's going to be?
It should be 3.
All right, 3 left over. Take a look. All right. Did I not run the right one? That is not right. Oh yeah, 5 modulo. I did it backwards. 8 modulo 5. Like 8 divided by 5. So yeah, there we go. I did the evil trick thing. One of the best ways I use to kind of help yourself imagine this item is, at least for me, one of the best ways I did it was, imagine you're a teacher for first graders, we'll say, even just elementary school, even just kindergarten, doesn't matter. You're teaching little kids. You're doing maybe even you're at a daycare. You have 8 cookies and 5 kids. How many cookies do you have left over? You're going to keep those 3 cookies, right? You're not going to try to separate them because no matter how, if you've ever dealt with little kids, you cannot cut up those 3 remaining cookies to make those kids happy, right? You can't cut them. They're not going to be okay with that.
You just eat them yourself.
One of those kids is going to be like, they got a bigger piece, right? There's no way that you can cut up those 3 cookies to make all 5 kids happy. Someone's going to claim that another kid got either a bigger piece or that kid's piece has more chocolate chips in it. Something. They're going to complain about something. That's what kids do. Which is actually why I do always challenge you with this question, which is where I say, if you have 5 cookies and 8 kids, how many cookies do you still have? You don't give out cookies that day. If you don't have enough cookies for all the kids, you don't give them out. You still have 5 cookies. So that's the way to keep in mind. So that's why this came back as 5, because 5 was the remainder. 5 can't go into 8 at all. So your remainder is 5. So why do I say this? So one of the real cool tricks of modulo is that it can keep a number within a certain range, even if it goes above it. Watch this. So if we let's do this quick. So again, we'll do 5 again. So we'll do, or 4 players. So player 0 goes first. So modulo 4, what's our result? 0 modulo 4. Yeah, 0, right? We get 0. 1 modulo 4 gets what?
1.
Yeah, 1. 2 modulo 4. So player technically 3. 2 modulo 4 does what?
2.
Yeah, 2, right?
Zero.
We're still under the modulo. So if you try to divide 2 by 4, it doesn't go in anything. So 3 modulo 4. What's left over? So 3 divided by 4, what's the remainder?
3.
3, right? We still got 3. So there's our 4 players. Now for the real test. 4 modulo 4. What do we get?
0?
Yeah, there's nothing left over, right? 4 is divided by 4 evenly. So we get 0. 5 modulo 4, what do we get?
1?
1. 6 modulo 4, what do we have?
2.
2. 7 modulo 4, we have what?
3?
3. And then 8 modulo 4, we get,
0.
do you see the pattern?
Oh,
What modulo helps us do is we can have a counter that we never have to test to see, do we need to bring it back to 0? Instead of trying to keep track of it yourself and be like, oh, I hit player 4, I need to reset back to 0. Instead, we can just modulo by a number and keep it within the range of 0 up to, but not including that number. So by modulating by 4, we keep our number between 0 to 3. So now if we go back to our LiarsDice here, we want to make sure our game will cycle through our players from 0 up to how many players we have, right? The length of our players item, right? We have our players array right here, our players list. So what we actually want to do is do active player modulo players.size. And then as long as we do that, we can now do active player plus plus to then make the next player go. So player 0 goes first. They do their system. Player 1 goes next. We know 1 modulo, let's say 3 players, is going to be 1. They don't end the turn. They make a new claim. Active player goes to 2. We pop back up to the top, and we're going to get the second player now. We're going to get the third player now. So we're going to do active player 2 modulo 3 leftover 2. So we keep that number 2 index. So that's player 3. Let's say they don't end the turn. So they don't end it. Active player hits 3. All true. Our active player modulo 3, our 3 modulo 3 is going to be back to 0. Player 1 goes again. Our first player gets to go again. Like I said, what we might do is tomorrow, just to make sure that modulo makes a little more sense, I do have a really nice, nice little, very easy algorithm that we can do before class. So we'll do one of those as a start, because modulo is a nice item to know about. There's a really cool, some fun tricks with it that I can even show for those who are interested. So modulo has some useful capability that people, when you first learn about it, like, when would I ever use this? Why do I care about remainders?
I know checking if it's even or odd, I've used it before.
Yes, that's the most common one that people know about. Most commonly, people know to use the modulo for even or odd. There's 3 real behavior. There's like 3 behaviors that modulo has: determining if something, well, like even or odd, determining if something is divisible by something, if it is divisible by something, and then the third option is this one: keeping something within a certain range. So it's got a nice part of that.
Cliff, should active player be 0 right now then?
No, because
Or
0.
does size do the because I'm getting caught up on the fact that if it's, does size do, like, if the length of the array or the list is 4, does size do
Right, that's that weird thing that
0, 1, 2, 3, or does it do 4?
No, that's a fair question, because there's this myth out there that developers count with 0, 1, 2, 3, that we count by 0. We don't actually count, and that's where I like to always like shatter that myth. Developers don't count by 0. If I have nothing that I have more of, there you go.
I don't know why this is confusing.
How much gum
all
do
of a
I have
sudden.
here? Oh, damn it, that's like bright. How much gum do I have in this?
4.
Yeah, I have 4 pieces, right? I count 1, 2, 3, 4. Even as a developer, I count starting at 1. The
Yep.
trick for a developer, though, is that if we ran a race, the first person across the finish line would actually be the 0th position. So we have 0th positions, but we count like a human. We count normally.
Okay.
So when we do size, we're counting how many items are inside of it. We count normally. So size would
So-
actually give us 1 through something.
So aren't we technically the first time not accessing the 0th place?
Correct. We're
Player?
not, because the 0th player goes here.
Oh, already went. Got it.
Yep.
Yep.
Because the first turn, the first player's turn is actually unique. The very first player has to make the first claim. They don't have a decision of whether or not they can call a lie. They have to make one claim. Currently, as we said before, every round, player 1's going to go first every single time. We do want to change that later, but that's something we can deal with later. For now, we just want to make sure that the normal flow goes on for each round. Yeah, player 1, it makes the claim first, so they don't have to do any of the rounds, the turn stuff. So they prep the round. So this is pre-round information setup, and then we hit the actual turns, and now we're about to finish the round.
So if there's 4 players and the active player is now 4, and the active player goes into this while true loop, won't it get the first player, not the 4th
Correct.
player?
But
Okay.
in order to get to active player 4, that means active player 1, 2, and 3 had to go already. And 1, 2, and 3 are second player, third player, and 4th player. So active player is indexed. Don't forget.
Okay,
Active
all
player
right,
is
all right.
indexed.
Yep, Yep. Okay.
Yep. Active player is indexed. Size
got
is
you.
not. Size
Okay.
is not indexed.
I got
So
you.
yeah, active player. And if you really want to, you can do this position, if that makes it easier for to see what's going on. So it's the active player positioning, if that makes it a little easier to follow what's happening. Because yeah, active player is not going to actually represent the actual number of the player. They're one above. Sorry, they're one below. Active player 1 is actually player 2. Active player 2 is actually player 3. Active player 3 is actually player 4. So far, so good?
Yep.
Okay, good.
Thank you.
No worries. That can be a little confusing. That's why I'm a little annoyed at myself that I didn't just start with just 2 static players and ended up going with a list right away. But it's all good. This is good stuff for you to grab onto. So, whew. I got that. 1, well, true. That should go through. So now if we hit this line here, we know we have a lie called. So now we have to first validate if the claim is a lie or not. So now have to check the claim. So not is valid claim. Let's go ahead and do down here. Do a private boolean is a lie. And in order to determine whether or not a claim is a lie, so we do need the claim, which that's a global item. That's part of the object class. So we don't need to send it. We need to confirm that all the dice, right? We need all the dice. Correct? Now the players is a list that we have access to, so we're good there. But we need to know all the dice. We need to count up all the dice, right? Let's confirm this. So me and Christian were playing our game. We had to, and now let's say again, most likely it was the opposite way. Christian would call my dice a lie. In the physical game, what we would then do is we would then lift up our cups, push the dice into the center, and we would look at all the dice, right? And we would, now in the table game, we would just look for those dice that were part of the claim, right? We wouldn't care about any other values, right? Could we do that here too?
You mean if you go through like every cup
Yeah, we
and
could,
just find how
Yeah.
many?
and we could always
yeah.
ask each cup, how many of this die do you have?
Mhm.
So instead of trying to actually ask the cup for all of its dice and then trying to count them all up, we could actually create a method in our cup class to return a
Specific
count
ones.
of a specific die. Let's do public int count value, int value, int count equals 0. And we want to go, we want to go through every single die, right? We don't know the order of the dice. We don't know if they're not sorted. And there's no real need to sort the dice. So we have to go through each die. So or var die and dice if die dot get value is equal to value. Helps if I do the parentheses. I'm going to do count plus plus. Probably a lot easier, right? You go through the dice once, you find the dice. So there are some more complicated ways of doing this. You can, of course, build a hash map, counting up all the dice. But again, all we care about is the value of the claim. All the other dice that are in the collection that's on the table, we don't care about those. Whenever, if we were actually playing in the real world with 4 players, think about that. 4 players with 7 dice each. There's no reason for you to sort out all the dice and look at all the 1s and all the 2s, all the 3s. If the claim was there are 6 4s, you're going to pull out all the 4s and see if there's 6 4s, right? Yep. At least that many again. At most that many. Again, you can actually you can make a claim that is lower than how many there are. So if you say that there are 3 4s and there's actually 7 4s, you're fine. Your claim, unless you just can't claim to have that there's more than what's there. You can claim that there are 4 4s or less or more. So, you know, when we said that there were 3 3s, there has to be at least 3 3s on the board. If there's any more, we don't care. Let's go back to LiarsDice now. So now we have a new little method there that's going to help us out. And again, we're going to do another count. In count, start at 0. We're going to loop through each player. Now here's a key thing here again, what I just said there. Technically, as soon as our count hits our claim value.
I can't even taste those. Yeah, but
Still hear you, Christian.
Oh, my bad.
So I'm sorry you can't taste things. That sounded so sad. I can't even taste those. So bad. Anyway, so from the beginning, let's just go through it all. So there, I'm going to leave the optimization of this method up to you guys. You guys can optimize this method if you want. There is a way to make this method run better. For the minimum, all we're just going to do is going to run through all the players and ask them for how many of this die, this value do they have. So for player in players, and I need to do count plus equal player dot. Oh wait, the player doesn't. We can't get the cup. We put that method in the cup, but we can't access it from player yet. What was that method type I said that gives us access to another, to a composition classes method? We did them here. Do you remember what I called that?
Is it access method or what'd you call it?
Method reference?
Yeah. It's like a
The method
rollover
override?
method.
I don't know.
No, because you're like passing. You're just
Say that.
passing.
TH.
What?
What?
Passing
Wait,
through. Right?
Oh, okay. Yeah.
Pass through.
pass through. Okay.
So we're just going to do count value, and all the count value method is going to pass the count value method from cup through the player method out to the public area. So again, we make this one method from cup public without making the cup itself public. That's the idea. So it's passing through. Got that. So back to LiarsDice player dot count value. We send through the claim value. Why is it not like that? Void. Huh? Oh, I did a void. Whoopsie. And then do return. There we go. Add up all the counts, and then all we need to do is make sure that our count is greater than or equal to, if our count is less than our claim count, then we have a problem. So turn count is less than our claim count. That means it's a lie. So if our count is less than our claim count, the player lied, right? That follow through. We count up all the 4s, and if we count up all the 4s and it is less than the claim that the player made, they lied. There were not enough 4s in the collection. Cool. So you can do that. Let's do back up here. Lie. Oh, that's right there. Okay. Oh, right. No, wait, no, that should be fine. Semicolon where? Oh. There we go. No. L. It's the L. There we go. If it is a lie, so if it lies, what do we do? So if the player lied, what do we do?
Remove a dice from that player's cup.
Very good. And so who would be the one that loses the die? Is it the active player or someone else?
Isn't it the one who made, no,
The one who made the claim, right?
yeah.
Who made the
Yeah,
claim?
The one before him, so
Right, so
active player -1.
You got it. Yep. So players dot get player get, I don't know what I'm doing, active player -1 dot. Oh, let's see, do we have a way to remove the dice? We do not have a way to remove the die, at least not in the player class. We know our cup class does. So what do we need to do?
Lose a pass through.
Pass through.
Yep, very good. See, we're getting it. It's starting to make sense. Void, remove die. Just do cup dot remove die. There it is. Now let's say the player didn't lie. What happens next? What happens?
Active player loses, or
Yes.
yeah,
Else
okay.
players dot get active player, the one who called the lie, they lose a die instead. So one of those two players are losing a die. Either the active player or the previous one is losing one. Good. Die from loser. We also want to remove that player if they are out of the game. Right? So we want to do another thing we would do if. Let's see. How do I think we put in a method that allows us to know if the player's out. Let's go back to the player class for a second. We do. Player is out. So we can do that. Back to LiarsDice. If players dot get active player -1 is out, we're going to do players dot remove active player -1. I'm going to remove that player from the game. All right. We do the same thing here, just with the non-active player, with the active player, so that one. Sound good? Do we see anything strange about this code here?
It's repetitive.
It is a little repetitive, right? The only difference is this -1. So probably instead of doing this code, what I can do is take this code here, move it outside the else, and instead just do active player minus equal 1. Now I don't need the else anymore, right? If it is a lie, the active player that's getting damaged is the active player minus 1. Otherwise, the player getting hit is the active player. So now I don't need the else, and look what I just did. I cleaned up my code a little bit. Kind of nice, right? Very good. I like the impressiveness by Christian's face. He's just like, oh, I didn't think of that. Simplify the code. What there? Nope, good. Awesome. All right, so we move the players out. And then the last thing we need to do is determine if there are at least 2 players, right? If players.size is equal to 1, what does that mean?
They won.
The game's over. Yep. S out. Game over. Players dot get 0 dot get name wins. But that means we have to tell it to stop running the rounds, right? Because that's another thing we have. The run rounds is another, technically going to be another looping system, right? We need to be able to tell the overarching system, hey, we don't need any more rounds now. Don't do anything else. No, let's do this again. Boolean. We'll go ahead and say return false. Otherwise, return true at the end of a round. Sound good? Do that. There's our round. Let's read it out, make sure it makes sense. Shake all the cups. We say the player's turn. We peek at that first player's dice. We get the claim. We set the active player to player 2. And then we continue running the round, running a turn until the round ends. If it doesn't end, we increase the active player until someone calls a lie. Once they call a lie, we check if that claim was a lie. And if it is, the previous player will lose the die, it will get affected. If not, the current active player will get affected. Whoever's affected will lose a die, and if they're out of the game, we remove them from the game. Once we have only 1 player left, that player is considered the win, and we return false. Otherwise, we say, yep, the game continues. So go back to our liar's dice here. We're going to go say now, while true, Boolean continue game equals run round if not continue game break. Sound good? Let's see if this works. Now I'm going to test it. We're going to actually test this code and see what happens. It may break. We may have some bugs, but let's just see what happens right now. What we're actually going to do is, like I said here, we have the no player. So we go back to main. Let's clear all this. We're just going to simply do, sorry, not that. Liar's dice game equals new liar's dice. We'll play 2 players to start, nice and simple. And then game dot, what do we call it? Oh, that's it actually. We don't actually have to do anything else because the constructor will actually play the game. Cool, I actually didn't realize I did that. So we just instantiate the game and that should do it. It should play the whole thing. This should be our whole line. Let's see what happens. You hit play. All right, who's playing?
Me.
Who's me?
Oh, Jeremy.
Okay. Sorry, I don't have a. I had your block has been lit up the whole time. I think there's some sort of background noise triggering the square, so I didn't realize it was actually you. So Jeremy, who's playing with Jeremy?
Let's get it.
What's that? They're scared.
Christian wants to play.
I'll play.
All right. Good luck, Jeremy. Yeah, that's right. Okay. I don't know why I had a brain fart trying to spell it. So the one downside of this is that the two players are going to know exactly what each player has, but it's fine. We're testing still. All right, Jeremy, you get to make the first claim.
6.
So you're going to say, so remember, this is the die value. You don't have any 6s, by the way.
Oh. So I just claim I have like a 3 or 2 threes. Or
What's
no,
that? So you're trying to claim what you have and what Christian has combined. So you're saying how many of this die is on the board. Again, the slight downside is that Christian can see your hand. So, but again, you'll also see Christian's next time too. So for the time being, just create a claim of dice you actually have, just so we make sure that works.
So, so I have 3 5s and 2
Sure.
2. So
5, so die value 5, and you have 3 5s.
Yeah.
So Christian's turn, press enter to continue. Let's see, so Christian has 6 4 6 5 3 2 2. The current claim is that there are 3 5s on the board. What are you going to do for what do you want to test first, Christian? The fact that we're going to go straight to testing for lying to see if you lose a die, or do we want to go and just test to see if we can do a second claim?
Do
What do we want to test first?
the lie. He's
So we'll see
lying.
it. So what we're going to say is Christian wants to see that if the game will realize that Jeremy did not lie and see if he loses a die. So the goal here is that Christian should lose a die. Something I realized, we have nothing printing out to say what happens, so we won't know until the actual turn hits. So liar. So Jeremy still has 7 dice, so that's good. So Jeremy, now I want you to lie.
I have 4 5s.
5 and 4. Christian's turn. Christian only has 6
look at
dice,
that.
so he did lose his dice. So that did make us realize we have nothing printed to the console to let us know what happens after a lie was called, which is probably not good, right?
So,
We do see that that a false lie was called, that if the other player told the truth, the one who called the lie will lose a die. So now Christian's going to call this out as a lie. We should see Jeremy lose the dice, lose a die. Jeremy did not. Dang it.
All right, Jeremy, you broke the game and you hacked it. So
That's
now you
good.
can't lose. All right. Sounds
Well,
good.
let's see. I'm curious to see if Christian lost
Stack the
another
deck.
die. So let's see. Let's say there's 1-1. Christian did.
Woo! Yeah, thanks, Jeremy. Good luck, man. Yep, that's how we play.
Weird.
Yep.
Never challenge.
Jeremy keeps his die, no matter what.
So there we
Wow.
go. That's how Jeremy wins this. All right, let's see what happens. So let's go back to our thing. So we have a logic error. We know that there was a lie. We specifically made sure we lied. At least I think we did. Hold on, maybe not actually. Now that I think about it, we said there were 4 5s. Jeremy did not actually lie because he had, I think he actually had, he had 3 5s and
Oh man,
one.
and I had a 1.
so
Oh,
All right.
it was actually legit. So we didn't actually fail yet. So let's try this a different time.
Wait, the
I'm-
1-1, and now I'm gonna say
He has
no,
one.
There's one. Just stop winning, Jeremy.
I can't help it.
We're gonna have you say that there are 2 1s, even though that's a lie. I'm not gonna actually lose you dice. I want Jeremy to lie. So this time I'm gonna say that there are. I'm gonna
Oh,
say.
did the
Oh,
double thing again.
yeah, I did that again. So I'm gonna play. So Jeremy, you're gonna say that you have of the 2s, you're gonna have 10 2s in the game, which is not possible.
Perfect.
Do you want to call the lie this time?
Yes, please. Yes, Jeremy. Cheater.
Dang it! It lost. What happened?
Oh,
What broke?
Broke it.
Index 2 out of bounds. What?
the length of 2.
Because you put 10, right?
Yeah,
Yeah, but it should let you do up to 14.
That trigger 10 shouldn't be triggering
Anything
the
except for
lies. But let's see what happened. Let's do that again quick just to make sure that actually happens no matter what. As soon as we know that there is a lie, does that actually happen? So let's try that again. Jeremy and Christian, JC. We'll say again, we'll go with the number number
Six-
2, just
12
for now.
sixes.
We'll say 6. C's turn. Oh, goddamn. You have a bunch of 6s, of course. Yeah, you have 2 6s. Of course you do. Let's do... Oh, never mind. That's fine, actually. You have
That's, yeah.
6 2s, right. So 1, 2, 3. You have no 2s, only 3 2s in the game. So we call a liar. That actually worked. Why did the other one break? Interesting. And Jeremy did lose a die in this one. So the lie did call. It did actually call it out. Oh, I'm dumb. I know what happened. I realize what I did. Let's go back to the lie and let's see if you guys can figure it out. The end of the round. So run round. You go to is lie. The active player is -1. So we did a couple rounds, right? So we go here. We do get active player. Does anyone know what might have happened? This has to be indexed, right?
Yeah.
Since Christian and Jeremy went through a couple of rounds to finally get a call out, what is likely
Oh, it
the
went
value of
negative.
active player? Active player was not 1 or 2, 0 or 1, was it?
Mm.
It was probably 5 or 6, wasn't it? What do we do up here to make sure it's indexed? I need to modulo it, right? So we want to do, it's going to be easier. Active player equals active player modulo players dot size. This will bring our active player number back within the range of the game. We can even do, instead of active player, we could even change to affected player. Int. Just so we can see exactly what happens here. Affected player. Affected player. Affected player. Stop the game. That's why we were outside of the range, because we tried to get player 7 or something like that. So play again. We'll go ahead and do a couple rounds first, a couple turns. We'll go back and forth. JC. We'll do 1 1. We'll play that. Christian, go ahead and make a claim now. So you can make pretty much whatever you want because it's just 1 1.
5 2s.
How many 2s?
5.
5 2s going to claim. All right. He says there's 5 2s. Jeremy, what do you want to say?
Holy crap, I'm right. I mean, Jeremy, do what you want.
I was curious to see if Jeremy actually had paid attention.
I was not. I was looking at something.
So he would have actually
don't
had to
mind
see
what I
if that was
said.
true or not. He knows so you have 2 2s. Now the question you have to ask is Christian telling the truth that he had 3 2s or not?
Yes.
All right, so you're
Did
gonna
I
play.
tell the truth about the lie? Or did I lie about the truth being the lie? I was right. Think about it.
There you go. All right, Jeremy, what's gonna be your claim?
I'm gonna go 5 3s again.
5 3s again. So 3 and then 5. All right, Christian. He says there's 5 3s.
All right. I'm gonna say that is a lie because I don't remember what he had.
Well, we're
No
gonna find out. We don't actually know. Yep, that was a lie. So Jeremy lost the die,
Yeah.
and we were a couple turns in, so we know that
happens when
that
you don't
bug is
cheat,
now
Jeremy.
been fixed.
It's not cheating if you just do it randomly.
Touche. Fair enough.
He's like, I don't know. I'm just gonna say this.
Like 5 3s.
So we do know that that system works. Let's do a quick check to see if the claim validator works. So Jeremy, I'm gonna have you just. So again, this is the first round. You can make whatever claim you want, so it's not going to really help us. So we're going to do the 3 3s. So now, Christian, I want you to make an invalid claim. What's the
All right,
first
we
claim you
got-
want to do? So
It's gonna go down in the die value, so like 3 2s or whatever.
2
Try
3.
and do.
Die value must be same or increased.
Huh.
Something we want to do also is redisplay what the current claim is. We might want to add that back into the code. That might be nice to do. And this is why it's nice to go through and just test all the scenarios you come up with so you can see how your UI works. Is it necessary to bring the current claim back again? No, you don't have to, but it would be probably nice to see the claim a second time after we give the error. So it's something to think about. All right, let's do another incorrect claim.
He said 3 3s, so do 2 3s.
2. Must increment at least 1. And what's the other one we can do? The other bad one.
Oh, the same thing, right? Yeah.
Yep, must be a new claim.
Yeah.
There we go. And even the 2, 1 die value must be same or increased. So if we lowered the value and the count, it still tells us the value is the problem. So 4, 4, we see that that works. It accepts it. We're all good. So the game seems to work so far. Now let's just straight up cause people to lose dice and see if we can verify that someone, once one of these two get kicked out, the game will actually end. So we'll call a lie on that. Jeremy lost another die. So we'll say there are 1, 10. Go ahead and call that a lie because that's of course a lie. Jeremy lost another die. Sorry, Jeremy, I think I'm kicking you out. I just want to do this quick. So 1, 10. Calling that a lie. 10. We'll call that a lie. Jeremy has 2 dice left. So as soon as he loses this one, oh no, you said all dice have to be on. So 1, 1. We did check that. We did the is out. So, oh, that's not what I wanted. So we're going to play that actually. Actually, we'll do lie. Christian will lose 1 die. So 1, 10. Christian will say that's a lie because there's not even 10 dice on the field anymore. Only 7 dice. Jeremy's down to his last die. 1, 10. You of course call that a lie. Game over, Christian wins. The game kicked out Jeremy, noticed that Christian was the only player left, and announced him the winner. So far so good, right? So this is actually a functional game. What I want to do now is I'm actually going to push this code to GitHub. Git add-a, git commit-m, LiarsDice complete. Not fully. There's a couple things that we can do to improve this. And I'm going to add those to the main class here. A couple things we can do to improve this. Improvements that can be made. UI or print out lie information or end of round information. There we go. End of round info. Call out liar and declare who lost a die. Declare when a player is removed from game. So we know that a certain player left. Another thing you do to improve the game, improve overall printouts. Clear console at start of next player turn. Note how we didn't do that. That when the next player had to hit enter, they could still just look up a little bit and see the other information. So you do want to clear that out and make sure it's at the top. So you want it to kind of do something like this where it does that. Let's say press enter to continue. So we want that. So the example, actually, let me see if I can do a better example of that. So we play it quick. We'll do when I do 1, 1, what should actually happen is, we do that, okay, dang. What we should see is that it should kind of clear everything out and this line should go to the top. And so we shouldn't be able to see this dice. We don't want to be able to see this. So look into how to do that. There's a couple of tricks. I don't think Java has a explicit way of doing it, but there are some techniques that you can bring in. So shouldn't be too difficult. 5-minute Google search, you can find that. That's an easy one. And the last but not least, what was it? Allow user to enter how many players. So instead of doing the static number of 2, you want to let the person be able to enter how many. Just to see it works, quick. Let's go ahead and do a player of 3 just to check that. Make sure this actually works. I'll play. Who wants to see their name on it next? Yeah, man.
I'll go.
Whales in. Who else? Cullen, Richard, or Chang? Who wants to come in with us?
We got 500 on Cullen.
Cullen, you gonna come in? I don't know if you lost him or something. Did he say he's gonna be right back? Or should I have my chat thing open? I do have a chat message. No, Jeremy said he's going to restart his computer. Not sure what happened to Cullen. He's gone quiet.
I switched my bag. I got 500 on Jeremy.
Jeremy, you good to come back in?
Yeah, I thought I was already in.
Right.
Just checking. I wanted to see if anyone else wanted to come in. So I'll go first. I'm going to say that I'm going to say there's 3 3s. So I might even, and that's something I'm thinking I might even do. Maybe switch those around. How many and what die? But anyway, it's all good. This current claim is 3 3s. Will, what do you want to say? Do you call me a liar or do you want to play?
I'd say 5 4s.
So you're going to play and say there's 5 4s. So 4, 5. All right, Jeremy, he says there's 5 4s. You have 2 4s. You lying or are you going to play?
I'm gonna call a lie.
I'm going to say it's a lie. And again, we don't know what actually happened. This is this bit here. That's this improvement. So I'll get, and again, also, ooh, that's the one big improvement. Major improvement. Each round should start with a new player. So it shouldn't always be the same player playing first. So I shouldn't, so in this round, it shouldn't be me making the first claim. I made the first claim last time. So there's a couple ways you can do that. You can just say, well, I go first, then Will makes the first claim, then Jeremy makes the first claim, or you can also say, change it to whoever lost a die the last round could be the first person to make a claim. There's a couple ways you can do this, but the main goal is that each round it shouldn't always be the same person every single time. I should not be the lucky person to always get to claim the first claim. It should have a constant rule of who gets to be the first player for that round. Again, you can use the active player variable, very, very useful. That active player variable can be very useful in this item. So play around with that in modulo. So active player modulo, but the other ways of doing it, there's multiple ways you can do this. But each round should start with a different player. So I'm gonna go again quick. Just so we can see who lost the die. So I'm gonna say that there are there's 3 1s. Will did not lose a die, so I'm looking like Jeremy might have. Will, do you want to call me? Do you agree, or do you want to say it's a lie?
You said 3 1s?
Yeah. And you have 2 1s in your hand right now.
Yeah, I believe you.
Yeah, I was gonna say you're hoping that neither me or Jeremy have a 1. If one of us have a 1, I'm telling the truth. What's gonna be your claim? What's up?
I'm gonna go with 4 2s.
4 2s, so 2 and 4. Jeremy did lose a die. So we do know that worked. So unfortunately, what I'm gonna do now is I'm gonna have Jeremy purposely lose so we can just test to see, can we drop someone from a 3-player game and keep going with a 2-player game? Sorry, Jeremy, I'm gonna kick you out. So 1 1. Will's gonna claim that there are 2 3s, so we're gonna play. If we know that that's a true, and then Jeremy's gonna say that that's a lie, even though it isn't. Oh, Will actually lost a die. I apparently called that a lie and it wasn't. Apparently, Will actually did lie. My bad. 1 1. Will has a 6 still. So again, he's gonna say that there are 6. 2 6s, which is a definite. Oh, you gotta play, sorry. So 6, 2. They're gonna claim a lie again. 1 1. I was gonna say that he's gonna play and that there are 2 2s. They're gonna call a lie again. Now you're down to 3. 1 1. I should probably have lowered the number of dice we start with. Richard's gotta be right back. All right. Oh, I made this a little faster. Play and say that there are 2 3s. 1. Play. 3 1. Call lie again. 1 more. 1 1. Play 2 2s. And here we go. Nothing broke. That's a good sign. Let's see if Jeremy's actually out. Will's going to play and say that there is 3 4s, and it's back to me. So Jeremy was safely removed, and the game continued on. So you know that works. Not bad, right? This is one, again, this is what I would want to say is this is why it was beneficial for us to use a list of players. Because again, if we remove a player, regardless of where they are, it automatically readjusts all the indexes. So in this case, if Will had actually been removed, Jeremy would have moved into the second player position. Our size would have adjusted to 2, and our modulo system would have continued to work correctly. So the system, by using a list, we saved ourselves some issues that an array might have caused us problems with. Again, this is where you'll see between 95 to 99% of the time, you'll use a list in the place of an array. So back here again, each round should start with a new player. We see here again, we did declare that a player was, we didn't know that Jeremy was removed until we noticed, hey, he was skipped. So we do want to declare when someone's removed from the game. We want to improve the overall printout. So these are the improvements you can make to this program. And this is what I want you guys to work on this week in your off time. You're going to submit whatever you have on Thursday and actually on Monday. So this is going to be your week project. So you're going to be able to work on this for the week and into Monday. Most likely what'll happen is on Thursday. Yeah, what we'll end up doing is on Thursday, we'll end up starting moving back to the bank account system, I think. Yeah. I'll also grade everyone else's. So everyone should be working on this improvement. So Thursday, honestly, actually, yeah, no, Monday. Yeah, Monday, turn in what you do with this so I can grade it, see what kind of improvements you made. How did you make improvements? What did you do to make this game yours? So take my code, make it yours. Adjust it, clean it up, make it nicer. Other things you can do as major improvements, clean code. So what I talk about that, when we look at our run round's doing multiple things. A lot of these bits of code here could be pulled into, again, some smaller methods. This right here could be pulled into a smaller method where it's just the initial turn. So you can call that initial turn. The information that's down here, ending of the round, we could pull that into a different system, into another method. Extract that into a method. Even the run turn thing, some of the code here could be pulled into smaller bite-sized methods. So these can be streamlined and shrunk, and these are more text-based. So I might do that on my, I might do that on the side and share the finalized code next week. So you can actually see how I cleaned it up and cleaned the code. So I'll do that outside of class, and I'll just end up pushing it next week after you guys have a chance to update this code yourself. Last thing I want to say, by the way, I want you all getting your green squares for credit for editing this one. So do not fork it and work on it. If you fork and work on it, those commits will not get you green squares. You do not get green squares to commits to a forked repo. What you should do, there's 2 ways of doing this on the GitHub. If you choose to clone it, you come here and you do the clone method. If you do that, what you have to do is remove the .git file and then do git init again and make your own repo. Then you make a new repo on your side and push to that repo. The other option is to download it, extract it, and then run git init. When you download it, it doesn't include the .git file. And so it's not a repo. When you download and extract it, just the code, there is no git file folder, so it's not a repo. So as soon as you're done extracting it, you then git init, and that is a repo that is fresh, brand new, and it's yours. Either one of these ways, you want to start with a fresh local repo so that you can create a repo on your GitHub, the plus sign here, and then those pushes will contribute. Sound good? If you fork it, if you click this button here, it won't count. You will not get green squares. If you clone it and try to push to your clone, you're going to try to push to my code and you'll get told you don't have access. You are not allowed to push to it. It may say, oh, you can do a pull request, but I will not approve your pull requests because that means you'll be editing my code and then you won't get your green squares either. So do not do that. So if you clone it, remove the .git folder that it brings down and then git init, download, extract, get in it. Sound good?
Yeah.
All right. That way you get
when
your
you-
credit.
When are you going to upload?
I literally just uploaded the code. I'm gonna go
No,
ahead.
no, not the code, the video.
Oh.
The video.
I will try to get it up tonight. If you guys don't see it in the morning, the latest, ping me. Feel free to at me on the chat, send me a direct message, whatever. I'll try to get it up tonight.
All right.
All right. We're gonna meet up with cohort 8. It's already 8:30. Dang it, I'm taking too long. I will see you guys all tomorrow.
Peace.
We'll have a simpler class
Later.
tomorrow. We're gonna do some modulo practice. I will see everyone tomorrow.
All right.
Yeah.
Yeah.
Have a good night. Take care.